starting today to talk about vectors. Tomorrow we're going to talk about what's called dot products. But vectors is something you may have talked about in geometry, but you hear a lot in physics. The vocabulary behind what we're doing is the physics part, but the math all behind it, you guys already know how to do. Everything in here mathematically, you guys already know how to do. You can talk about area, you can talk about time, temperature, all those things. They can be represented by a single number, which is a quantity such as like force, velocity, that sort of a thing, in a vector form. We're going to talk about magnitude, these two words here, magnitude and direction of a vector. We already know what those two things are, and I'll show you in a second. But if when you're representing what a vector, what it looks like is it's a directed line segment. What does that mean? Okay, here's a line segment, and it has a direction on it. See how the arrows at point Q, it's pointing in one specific place? There's an initial point and a terminal point. What does the word initial mean? Where it begins? What's the terminal mean? Where it ends. Okay, good. All right, so let's talk about this for a second. The initial point, give yourself a little note here, is the beginning or the starting point. All right, terminal is the end. That's important. How do you find the magnitude, or what is the magnitude? It says it right here. What is the magnitude? The length. How do you find the length of something? What formula do we use? The distance formula, okay? So if it asks you for the magnitude of the vector, all you're doing is finding the distance from one point to the other. That's it. All right? If you're asked to find if something is equivalent, what does the word equivalent mean? Equal, okay? If a vector is equivalent, their magnitude and their direction is the same. The direction is just the slope. All right, so we're going to do an example here, and it's going to say, given the two vectors, are they equivalent? How would you prove it? You would do the distance to find the magnitude and the slope to find the direction. All right, very simple. It's just understanding vocabulary. Notice how magnitude is written. This means magnitude. Do you see the double bars on the left side, double on the right side? It's not absolute value. That's asking the question, what is the magnitude? We'll talk more about it in a minute. Now, how are vectors represented mathematically? You will always know that something is a vector mathematically if it is written as a lowercase bold letter. If it's bolded and it's lowercase, it's a vector. It's not a point. It's a vector. You're also going to see that a vector has pointy ends like that. It's not an ordered pair with parentheses. Huge difference. When you're writing your answer, if you put it in parentheses when it should be in a vector component or vector form, that's a lot of points off, because that makes a very big difference of what we're talking about. All right, so it says show that U and V are equivalent. How do you know by looking at these two things that they're vectors? Because they're lowercase and they're bold. Okay, well, how do you show that two vectors are equivalent? Their magnitude is the same. And what else is the same? The direction or the slope. So how do you find the magnitude? What did we just talk about? Magnitude is the what? The distance. So look at the V. Look at V vector on your graph here. Which one is V? The top or the bottom one? The top. Okay, so what are the X's? 4 and 1. And what are the Y's? 4 and 2. Okay, it doesn't matter the order here. I'm just going to say 4 minus 1 squared plus 4 minus 2 squared. If you did it backwards, that's fine. 1 minus 4 is negative 3. When you square 3 or negative 3, you get 9 in both instances, correct? So if I simplify this, I have 3 squared plus 2 squared gives me square root of 13, 9 plus 4. Okay, so let's do the magnitude of U. What's the magnitude again? It's just the distance. So what are my two X's? 0 and 3. So 0 minus 3 squared plus my Y's are 0 and 2. So 0 minus 2 squared. All right, let's simplify this. Negative 3 squared plus negative 2 squared. Well, what's negative 3 squared? 9 plus negative 4 squared is, so 9 plus 4 is 13. All right, did we prove that these are equivalent? Not all the way. Halfway, right? Their length is the same. They're the same length. The magnitude is the same. What's the second piece I have to do to prove that they're the same? I have to find the direction, which is the slope. The direction is the same as slope. So for V.
Just found their length.
So for vector V, let's find the slope. When my x's were, what were the two numbers for x? Well, let's do y's first. What goes on top? 4 and 2? So 4 minus 2. Whoops, that 4 looks weird. Hi. So 4 minus 2 on top. What's on the bottom? 4 minus 1. So 2 over 3. You guys agree? Okay, so let's do, what is this, u? Let's do the slope for u. What's the y's? 0 and 2. So let's do 0 minus 2 over 0 minus 3. I get negative 2 over 3, which becomes what? Negative 2 over negative 3 becomes 2 over 3. Are these the same? Yes. So the magnitudes are the same, and the direction are the same. So did you guys just prove that these two are equivalent? Yes. Now, 5 minutes ago, if I said to you, show that the magnitude and the direction are the same, you'd be like, well, what are you talking about? But now you know mathematically that magnitude just means, oh, find the distance. Direction just means, oh, find the slope, right? Does that make sense? Okay. So on your WebAssign, okay, when you guys do your WebAssign for 6.3, everybody listen, 6.3 WebAssign, all you have to do is the PDF because we're not going to be graphing these. 6.4 you have to put into WebAssign. But 6.3, just the PDF because we're just working on the mathematical portion behind this. Right? Yeah.
Are the U and the V always going to be like the same?
Say it again?
Are the U and the V going to be the same always? Like,
No.
or it's just that?
That was proving that they were the same, that they were equivalent, yeah. Okay, so we're going to talk about the component form of a vector. It's written here, as you see, as V1 comma V2. And what this is those like two vectors that we just had, each one of them had 2 points, right? So what you're going to do to find the component form is you take those 2 points and you're going to combine them in a certain way, and that's the component form of the vector. That creates the vector. Notice how this is written with these pointy things. When you find the component form of a vector and you don't put them with the pointy things on the side, that is wrong. It is not an ordered pair. I need you guys to really understand that. We're going to find the component form, and then we're going to find magnitude, and we're going to add them and subtract them and all that stuff, but you have to write it correctly, so make sure that you see that. One of the first questions that you're going to be asked is to find the component form. And you guys are looking at this and you're like, oh my God. Guys, it's not that hard. We already talked about all of this. Look at this. What is this formula here? This is the distance formula. All this is showing you is once your vector is in vector form, you don't need the y2 and the y1 and the x2 and the x1. What these little v's are, these are already the x and the y's of each vector already combined. I'll show you what that means in a second here. It's kind of like a shortcut. All right. First question you might be asked on WebAssign mathematically is going to be, find the component form of the vector. Is this a vector? No, it's 2 points. It tells you where it starts, where it ends, but it's not the vector itself. What I need you to write down is terminal minus initial. Where the vector ends minus where it begins. In order to find the component form, this is component form. In order to find component form, it's terminal minus initial. What is the terminal point for this vector V? -1, comma 5. What is the initial point? 4, comma -7. Now I'm going to say something and I'm going to repeat it probably 100 times today. First with first, second with second. If we are finding the component form, you keep the first part with the first part. What is -1 minus 4? -5, comma. Second was second. What is 5 minus negative 7? 5 minus negative 7 is 12. Now, you have just taken the 2 points and you have created your vector form. What goes on the ends of negative 5 and 12? Little v, little pointy things. That's telling me that you know you just took those 2 points and wrote it as a vector. To find the component form, they're going to give you the initial, they're going to give you the terminal, and you have to put them together. First with first, second with second. Now, if I asked you to find the magnitude, right? If you had these 2 points, you guys could find the magnitude. You would say y2 and y1 together, x2 and x1, but we've already done that. We've already put the x's together and the y's together. So in order to find the magnitude, the way that you would do that, what do we call this, v? The magnitude of this vector v is the square root of, what's the first part? Negative 5 squared, plus the second part is 12 squared. Once you have already gotten into vector form, you don't have to worry about the x's together and the y's together. That's already been done. Your 2 x's together gave you the value negative 5. Your 2 y's together gave you the value of 12. So you would say this is the square root of 25 plus 144, square root of 169, right? So what is the magnitude of vector v? 13. Good. Very good. So anytime you're in vector form, all you have to do to find the magnitude is take the first piece, square it, second piece, square it, add it together, take the square root. It's like the distance form is already condensed for you. So let's talk about a couple things, all right? Graphically, you guys are not going to have to graph, but I want you guys to understand how, God bless you, scientifically this is related to mathematical, okay? Think about this. This is our initial vector in green. All right, see vector v? How does vector v in green compared to yellow? Graphically, what does it look like? It's shorter. By how much? A half. Mathematically, how could you look at that and tell that? What are you multiplying the v by? The 1/2, right? That's called scalar multiplication. You're multiplying by 1/2. Compare v in green to red. What's the difference? It's bigger. By how much? How much bigger is vector? It's twice as big. How do you know it's twice as big? There's a 2 in front, all right? Compare green to blue. It's the same length, but opposite direction. Mathematically, how would you know it's the opposite direction? There's a negative in front. Okay, so what 2 things are going on in pink? It's 1.5 times larger, and it's in the opposite direction. You guys see that? Negatives change directions, right? Instead of going up, you go down. Instead of going left, you go right. That sort of a thing. And you're just multiplying. That's all that number in front means is you're multiplying. That's it. So what we're going to do now is we're going to combine. We're going to do this adding and the subtracting and all that stuff, but we are not graphing it. That's why on 6.3, you're not putting it into WebAssign. If you ask me, I'm going to tell you yes, you have to. Because I've now said it for the 3rd time, and it's on the video. 6.3, you do not have to enter the answers into WebAssign. But when you graph them, when you put them together, when you add them or subtract them, this is what it looks like. But we're not going to do that. Okay, what I just talked about a second ago, and what I'm going to keep talking about, is we're going to add and we're going to use scalar multiplication. 1,000,000 times, guys, I'm going to say first with first, second with second. If you're going to add 2 vectors, right? You're going to add 2 vectors. Vector u has 2 parts to it, part 1 and part 2. Vector v has 2 parts. So look, part 1 stays with part 1. Sorry. Part 1 stays with part 1. Part 1 of u, you add to part 1 of v. And same with the part 2s. You'll see what I mean in a second. Do you see how this k out in front? This is called scalar multiplication. What are you doing with k? You're just distributing it. So you're multiplying by everything inside. It's all stuff you've done before with points. Now it's just with vectors. If there's a negative out in front, what are we doing? You're multiplying by a negative. You distribute. Now, if you have a minus sign in the middle, minus is the same as plus and negative. I am going to urge you guys, if you have a minus sign, to add, to change, and then distribute the negative before you combine. And you'll see why in a second. Just makes life easier. The hardest thing for you guys is going to be the signs. Like when we just had -5 minus a -7, and some of us said 2 or -2. That's where you guys are going to make mistakes. Not with anything conceptually. It's going to be just silly math computation. Again, the graphing part, you're not going to have to do, but this is what it looks like when you graphically add or subtract vectors. So, this is the problems that you're going to now see on your website. It is as easy as it appears, I promise you. But look, how can you tell that we're talking about vectors here? The things, the pointy things, I agree. Oh, how else? Because the V and the W are lowercase and bold. So what is letter A asking us to do? This is what I expect to see for homework, so don't turn it in with just answers and say, but I did it. This is, I'm telling you what I'm expecting to see and what I have to see on your test. Letter A says 2 times V, correct? So what you're going to do is you're going to say, okay, 2, and then you write down vector V. Not negative. What am I doing with the 2? Distributing. So here and here. What is 2 times -2? -4. What is 2 times 5? 10. There is your scalar multiplication. If I said to you guys, what's the magnitude? I'm not asking you to, but what is the magnitude? How would you figure that out? You'd say -4 squared plus what? 10 squared. And then you just say 16 plus 100, square root of 116, and then simplify it if you can. Once you're in vector form, you don't have to worry about the y2 and the y1 and the x2 because that's already been combined. That vector form is already the y's together and the x together. Yeah.
Well, we have to find the distance in vector form.
No, because it's already done for you. Good question. All right, let's look at B. What is B asking you to do? Subtract W from V. Now, where we'll make a mistake is we'll not write the numbers down right. We'll miss a sign. We'll put them in the wrong order, something like that. You've got to pay attention. I'm going to do this in 2 ways, and I'm going to show you how I think you should do it. And then you guys can decide if you want to do it the way that I think you should, or if you want to do it the way that some of you are going to just insist on doing it. What kind of a problem is this? What kind of a problem are we dealing with? Subtraction. Okay, this is where sometimes our signs get messed up. If I were you, okay, this is the Meadow side. This is what I would do. I would initially take that minus sign, I would change it to a plus, and I would distribute that negative. So I would change this to a plus, and I would change this to a minus. It makes life easier because now I'm going to say this a million times. First goes with first. So 3 plus 2 is what? 5. Second with second. 4 plus -5 is -1. There's your combination. If I asked you to find the magnitude, you would say the square root of 5 squared plus -1 squared. Figure it out. Now, if you don't distribute that negative, you don't have to. That's fine. But this is where some of you will make mistakes. Remember, first goes with first. So it's 3 minus a -2. What's 3 minus a -2? How many? Okay, we had 3 people say 1. When I said over here 3 plus 2, not one person said 1, right? It's very easy to make a mistake, guys. When you have minus a negative, it becomes a positive. So 3 minus a -2 is +5. 4 minus 5 is -1. Did we get the same answer? Yes. Do I think every time you have a minus sign in between 2 vectors, you should change it to a plus and distribute? Yes. Again, it's up to you guys. All right, let's look at C. What is C asking us to do? Take V, which is -2, 5, and add it to 2 times 3, 4. Yeah? So what do we do first? We distribute the 2 first. So this stays negative 2, 5, plus 2 times 3 is 6, 2 times 4 is 8. Now we have one vector plus another vector. So first with first, what is negative 2 plus 6? 4, good. What is 5 plus 8? 13. And if I asked you to find the magnitude of that, you would say 4 squared plus 13 squared, and then go on. Make sense? All right, good. Good. This wasn't bad. All right, so this is all the stuff. This is the addition properties and the multiplying by 0 and all that stuff that you guys learned in the 2nd grade. But the same properties, the associative property, the commutative property, they all apply when you're working with vectors. When you're talking about addition, scalar multiplication, math is math is math. Doesn't matter what we're talking about here. All right, again, this is the same slides that we've seen before. This is the adding or the subtracting and the multiplying. You guys are not going to have to do this. You don't have to do this on the web assignment. You're not going to have to do this on your test. We're just focusing on the math computation behind it, not actually graphing them or anything like that. So here is what WebAssign is going to look like. It's going to ask you a very simple question to do all of these and then sketch. You don't have to sketch. I just want to see the math behind it. I want to see that you take the u and the v and you multiply it by the 2 and, whatever you need to do, I need to see that. But I want you to also see that there's questions on WebAssign that are going to look like this. And some of you are sitting here going, man, everything was so easy until she does this, right? We're going to do these 3 examples. And after I give you one explanation of one thing, you're going to go, oh, okay. This is another way to represent a vector. First of all, looking at this, how do I know they're telling me this is a vector without telling me? Tell me you're a vector without telling me you're a vector. Because the u is lowercase and it's bold. But it's not in the pointy things. It's written differently. But you can rewrite it in the pointy things. What is the first value you see? What's with the I? What's with the J? That's it. The I and the J just represents I is the first vector, first piece of the vector. J is the second. How do you know that I is going to come first? Because I comes before J in the alphabet. So rewrite vector V. What is this one? Negative 2, negative 1. Why is it 1, first of all? There's no number in front. And why is it negative? Okay, the sign goes with it. What is vector W? 15, comma, 0. You always have to have 2 values. You have to have the first part and the second part. So if you have an I but no J, put a 0 for the J. If you have a J and no I, put a 0 for the I. But I suggest you guys do that first, so it's in the form that you're used to seeing, and then just go ahead and do these. Let's do these 3 together, and then we're done. This says 3 times vector V. What's V? Negative 2, negative 1. Plus 2 times U. What's U? 3, 7. Okay. All right, do I combine first or multiply first? Multiply first, good. So this becomes negative 6, negative 3, correct? Plus, what's my second vector? 6, comma, 14, perfect. Now, do we have everything simplified now? All we have to do is combine. So first goes with first. What is negative 6 plus 6? 0. And then what is negative 3 plus 14? 11. How would you write it if they asked you to write it with I's and J's? 0I plus what? 11J. Do you have to have the 0? No. Hmm?
So for the distance formula, it would be 0 squared? Or just no?
You mean for the magnitude?
Yeah.
Yep. 0 squared, or you can just leave it. Yeah, if you were asked to find the magnitude here, you'd say 0 squared plus 11 squared, which is 121. Right? And then you take the square root of it. All right, let's look at the next one. I want to do these last 2, and then I'll let you go. So negative U. What's U? 3, 7. And then what's W? 15, 0. Okay. Whoops. All right, what should I do first? Let's distribute. So this is really negative 3, negative 7. plus 15, 0. Everybody with? All right, so first with first, what's negative 3 plus 15? Negative 3 plus 15. What's 15 minus 3? 12. And then negative 7 plus 0. Negative 7. Good. So write that with i's and j's. 12i minus 7j. And if you had to find the magnitude, 12 squared plus negative 7 squared, 144 plus 49, and then simplify, yeah? All right, now the last one, guys, pay attention to. This is where you'll have stuff on the test where it's so easy, but you're going to get all flustered because you got messed up with your signs. Write everything out first. It says negative 4w, so negative 4 times vector 15, comma 0, correct? Minus 3, and then vector u. 3, 7. Plus 2, and then vector v is what? Negative 2, negative 1. All right. Now, there's a couple ways you could do this. I'm going to do it my way first. Are you guys okay if I change this to a plus and then I put a little negative right here in front of that 3? Yes or no? Okay. So I have distribute. I have negative 60, 0. Plus, what's negative 3 times 3? Negative 9. And what's negative 3 times 7? Negative 21. Plus, distribute. Negative 4, comma negative 2. All right, now we have distributed everything. I have 3 vectors that we're adding together. I don't care if you add 3 together or 25 together. First stays with first, stays with first, stays with first. Negative 60 plus a negative 9. Negative 69 plus a negative 4. Negative 73. Second with second with second. So 0, negative 21, and a negative 2. Negative 23. And there's your vector. Now, some of you are like, why did you just distribute? Why did you change that sign? Watch, if you have negative 4, and then you have minus 3, and then you have the 3 and the 7 here, and then you have the plus 2. When you distribute here, I agree you guys are going to get negative 60, 0, correct? And then here's what happens here. When I say negative 3 times 3, you guys tell me it's negative 9. And then this is negative 21, correct? But what are you going to put for the middle there? A lot of you are going to put a minus sign. When you distribute, what did you distribute? Did you distribute a negative 3 or a positive 3? A negative 3. So if you distribute that negative 3, what sign's going to go in the middle there? A plus. Because that, if you take the negative with you to distribute, if you take the negative with you to distribute it, then it becomes, that's what I did here. I took the negative to distribute it here. It's going to change that sign in the middle. If you don't want to change that sign, what will happen here, this becomes negative 60, 0. If you keep that minus sign there, then you distribute a positive. 3 times 3 is 9, and 3 times 7 is 21. And then you'd have to distribute it after. I think anytime you have a minus sign in between two vectors, you should put a plus sign and put a little negative in front of the number so you remember. Because that's where you guys are going to make mistakes with the signs. You're not using a calculator on this part, guys. The whole portion of this is to understand how to combine these, not that your calculator can do it for you. So you're going to have to practice with this. But this is all 6.3 is just practicing with this stuff. Finding the magnitude, finding the component form. This is not due till Thursday, but you could get it done probably before the bell rings. And then we'll do 6.4 tomorrow, and then we'll just practice on Thursday, Friday.